Okay. Good morning, everyone. So we are going to discuss the problems of NEET previous year. Okay. So I hope all of you have solved it, right? I hope all of you have solved it. Okay. So we will start with discussing the concept first. ठीक है, हम लोग एक-एक करके सारा concept discuss करेंगे. अगर तुमने solve किया होगा, then it's well and good. If not, then you can get the idea that what kind of question is asked. Okay. ठीक है. So मैं एक-एक करके सारे concept discuss करता हूँ. Now, when you talk about first question, let's see question number 1. Okay. A ring of mass m and radius r rotates about an axis passing through its center and perpendicular to its plane with angular velocity omega. Its kinetic energy is, again, formula putting getting, right? Yes or no? Right? Formula putting getting. So तुम उसको डायमेंशनली चेक कर सकते हो, तुमको सॉल्व करने की जरूरत भी नहीं है, डायमेंशनली चेक कर सकते हो. Or you can just use half mv square, right? V is equal to r omega, simple. So answer is A, right? So it is super easy. Second one, a solid homogeneous sphere of mass m and radius r is moving on rough horizontal surface, okay, partially rolling and partially sliding. During this kind of motion, now, during this kind of motion, okay, so this is concept. So it is partially sliding and partially rolling. मतलब translational भी है कि नहीं? Rolling में translational और rotational दोनों होता है. So total kinetic energy is conserved. The angular momentum of sphere about the point of contact with the plane is conserved. Only the rotational kinetic energy about the center of mass is conserved. And angular momentum of the center of mass is conserved. This is a conceptual question. This is a conceptual question. Okay. Now think about it. What would be the answer of this one? Total kinetic energy is conserved? No, right? No, because when you talk about partially rolling and partially sliding, slide कर रहा है, तो slide कर रहा है, ठीक है, तो energy conserve नहीं रहेगी. See, only rotational kinetic energy about the center of mass conserved only, right? When you talk about only, then it becomes wrong. Okay, Harsha, ठीक है, right? Because answer would be B. Okay, angular momentum about the point of contact will be conserved. Okay, right? Got it? Okay, so the answer is B. Next, third one. ये concept है, इसको note करके लिख लो. ठीक है? Now, question number 3. The solid cylindrical mass. हाँ, गलत नहीं है हर्षा, but only, that's what I said ना, only. Rotational kinetic energy is conserved, but only, right? Got it? It means कि सिर्फ kinetic energy conserve होता है और कुछ conserve नहीं होता है. ठीक है? समझ में आया कि नहीं? इसीलिए, right? Rotational kinetic energy is conserved. No doubt about that. But only इसकी वजह से गलत हो गया. ठीक है? Okay, then calculate what would be the answer. So height is mgh. So loss in potential energy is mgh. And the gain in kinetic energy would be what? Tell me. Tell me. Half mv square, right? Translation kinetic energy plus half I omega square. है ना? और I क्या होगा? I, tell me, what is the value of I? Point of contact से I हो जाएगा mr square by 2. Yes or no? राइट यही ना, यस mr स्क्वायर बाई 2 होगा ना, तुम 2/5 क्यों बोल रहे हो? ओके, गॉट इट? सिलेंडर है ना? ओके, so just put it, you will get the answer. Okay, what would be the answer? Tell me what would be the answer. So ये 1/4 हो जाएगा, right? 1/4 mv square. So 1/4 plus 1/2 क्या हो जाएगा? 1/4 plus 1/2 is 3/4, right? So 4/3. Answer is B. Got it? Right, everyone? Got it? Now, fourth one, right? Let's see question of fourth. A particle of mass m is moving in horizontal circle of radius r with uniform speed v. When it is moved from one point to opposite, then think about it. Kinetic energy changes by half mv square by 4. Right? Tell me. It's simple, right? What will happen? Tell me. What will happen? What is the answer? Fourth one. I hope all of you can relate this, na? Right? It is moving in this direction. In this direction, we move in this. So change in momentum will be what? 2mv, as simple as that, because kinetic energy will not change. Kinetic energy will be same only, right? Okay, so momentum does not change, wrong. Momentum change by 2mv because direction changes, right? Okay, yes, very good. Now next, question number 5. Moment of inertia of a uniform circular disc about diameter is I. Okay, about diameter is I. Its moment of inertia about axis perpendicular to its plane and passing through a point on its rim will be. Tell me, this is based on parallel and perpendicular axis theorem, right? Tell me. This is a problem, simple problem based on both perpendicular and parallel. What's the answer? Tell me. Anushri, Gauri, Himashri, Abhishek, Shrishti, Uday, tell me. First of all, you have to apply what? First of all, it is like this, and you have to find perpendicular. So if it is like this and it is like this, both will be same, right? So when we use perpendicular axis theorem, I can say about the axis. So this Ix, suppose this is Iy, and this is this, right? So I can find perpendicular one will be what? Tell me. Think about it. Fifth ka answer, Harsha, it is C. The answer is C. Yes, because इसके एक्सिस के लॉन्ग कितना हो जाएगा? एक्सिस के लॉन्ग हो जाएगा 2i, राइट? है ना? क्लियर है? और पैरेलल एक्सिस थ्योरम यूज करोगे फिर उसका प्लस 4i, सो टोटल हो गया कितना? 6i. Now, sixth one. The moment of inertia of body about a given axis is 1.2 kg meter square. Okay. Initially, the body is at rest. In order to produce the rotation energy of this joule, the angular, again, it is a formula putting getting, right? Yes or no? Formula putting getting. Now, the angular acceleration initially, okay. So first of all, you have to find omega. Yes, on rotation kinetic energy, you can find omega, right? Yes. And then we know that omega is equal to omega naught plus alpha t. Omega naught is 0 because it is initially at rest, right? So you can find alpha. Yes or no? Tell me. So time you asked, right? Alpha is also given. Time is asked. So you can find time t. Alpha is given, right? You can find time t. Okay. Now seventh one. A fly wheel rotating about fixed axis has kinetic energy of 360 joules. Okay. When its angular speed is given. The moment of inertia of the wheel. Tell me. Guys, seventh one. Same formula putting getting, same as the sixth one, right? You have to find. So rotation kinetic energy is given. Okay, because it is flywheel, so it will have only rotational kinetic energy. Okay, yes. So the answer is C. Okay, eighth one, everyone. Question number 8. A particle of mass m is equal to 5 is moving with uniform speed this in XOY plane, means XY plane, right? Along the line this. The magnitude of angular momentum of particle about origin is. The magnitude of angular momentum of the particle about the origin is. Tell me. So this is based on what? Geometry, right? So we know that particle of mass m5 is moving with uniform speed this along the line this. Angular velocity we know mvr, yes or no? Right? Yes or no? Okay, got it? Right? Or r cross p, r cross p. Okay, tell me yes or no. Now using this I can say, okay, here, right, what is the slope? Tell me. Slope is 1. Slope is 1. Makes sense? Slope is 1, right? Okay, now if slope is 1, what can I say? Tell me, if slope is 1, what can I say? I can find the perpendicular distance now, r cross p. I can find the perpendicular distance, right? Got it? Because p is given. P is what? P is what? P is 5 into 3 root 2. P is 5 into 3 root 2. This is P. You have to find R and angle between these two. Got it? Tell me, got it? Right? So let's see. Let's see. So I can say, okay, when x is 0, y is equal to 4. When y is 0, x is equal to minus 4. So this is the line, right? This angle is theta. We know this. Velocity v is equal to 3 root 2 in this plane, along the plane, like this. The velocity is in this direction. Okay? Momentum across around the origin. What's the perpendicular distance? Perpendicular distance, tell me, between this and this. This will be the perpendicular distance, yes or no? Right? So I hope you can find the perpendicular distance between this and this. Agree? Right? Because this distance is what? This distance 4, this distance is 4. So you can find this distance, right? Are you got it? Okay, just put the answer, you will get. Tell me what you will get. I hope all of you got it. Tell me, question 8. All of you got it? What you have to do? Based on basic concept of momentum, angular momentum is r cross p. P we already know, which is 5 into 3 root 5. R is perpendicular distance, r cross p, which is pr sine theta. Now, this is basically the perpendicular distance, this distance. We know this point, this point. So this distance we can use, we can find using geometry, right? Just put it. Okay, r sine theta is this. So what would be the answer? Tell me. Tell me, everyone. This is 2. This distance is what? 4. Right? This is 45 degrees. So you can find it now. Hypotenuse is 4. Right? This is 45 degree. This is 90 degree. This is also 45 degree. Right? 2x square is equal to 4. Right? Okay? Okay. So you can find it. Okay. Sorry. Okay, I was just disconnected because the call, whenever I get a call, I get disconnected. Okay. Now, 8th one done, 9th one. I hope all of you understood 8th one. All of you understood 8th one? Yes or no? Right? Now, 9th one. If a sphere is rolling, the ratio of translational energy to total kinetic energy is given by. Now, this is just, right? This is just the ratio of I by M. Yes or no? Right? So, 9th one is, tell me. I hope all of you can solve it, right? Because translational is half mv square and rotational is half I omega square. Okay, got it. So depending on the value of I, you just have to take the ratio. Got it? Tell me, got it? What happened? Okay. Okay, you have to find translation by total now. So this is this plus half omega mv square, right? This by this. Okay. So 2 by 5 plus 1 by 2. Okay, the answer should be 7 by 10. The answer should be 7 by 10. Wait, no. 5 by 7, sorry, 5 by 7. Right? Okay, got it? Right? Next. Tenth, the speed of homogeneous solid sphere after rolling down inclined plane, right, of vertical height h from rest without sliding is, tell me. Tell me. This is the same concept now, work energy, right? This is the same concept that we used in previous question. When we talk about potential energy, what is the potential energy? Loss of potential energy, mgh, right? This should equal to total energy, total kinetic energy, which is half I omega square plus half mv square, right? In previous question, it was cylinder. In this question, it is sphere. So it is exactly the same question. The only thing that will change is I. Okay. Now, 11th one. 11th one. A solid sphere disk. 10th understood, everyone? 10th understood? Tell me. Right? It was same problem. The only thing is cylinder is replaced by sphere. Okay. Now, 11th one. A solid sphere disk and solid cylinder, all of same mass. Right. This question is asked in JEE also, I guess. This question is asked in JEE. Tell me. I hope all of you remember this, right? I hope all of you remember. My voice is breaking in between. Everyone, my voice is breaking. Okay. Now tell me, this is a conceptual problem, very good problem, right? Tell me, Himashri, Harsha, what is the answer of 11th one? No, Vishnu, it's not D, right? It's not D. Because C, right? What is different in all the cases? K is different. Now tell me, radius of gyration is different. Yes or no? Tell me, yes or no? Right? So when you talk about K square, when we talk about radius of gyration, it is different. So whose K is most? Tell me, whose K is most? Yes, solid sphere. Very good, right? Very good. Okay. The answer is solid sphere. Okay, got it? Okay, next. 12th one. 12th one. In a rectangle ABCD, where BC is twice of AB, the moment of inertia is minimum along axis through which axis? Tell me. BC, BD, HF, EG. Yeah, disk and center will come same time because again they have same value of K. Now think about it. When you talk about this, right? Okay, moment of inertia. What is the meaning of moment of inertia? It is basically, think about it now. When you talk about moment of inertia, it's basically how mass is distributed along some axis. Yes or no? Tell me. Yes or no? Right? For example, if you see this, for a disk, take either a disk or a cylinder. Take either a disk or a cylinder. Okay, moment of inertia is same. Yes or no? Tell me. Yes or no? Just take example of this. Just take example of cylinder. Okay, right? But now, if you take this axis like this, tell me, axis like this, what will happen to moment of inertia? It will increase or decrease? Tell me. Decrease. Sure, Harsha. Increase, na? It will increase. It will not decrease, right? Because mass distribution is more now, right? Because doesn't matter if it is one surface. See, in this, it is a disk or this whole length or length like anything. It doesn't matter. It is half m r square. As simple as that. Okay, right? Got it. So the answer is EG. This axis, right? Got it. Tell me, Harsha, got it? Everyone got this? No, it is not diameter. It is not diameter, na, right? See, when I take to the example of cylinder, right? It is perpendicular axis. When you talk about diameter, right? See, I'm talking about the perpendicular axis, right? Cylinder along this axis, okay, along this axis is mr square by 12, right? Okay, I'm talking about perpendicular axis like this. Okay, talk about cylinder, na, right? When you talk about moment of inertia, think about it, right? It totally depends on how mass is distributed. Yes or no, right? Okay, when you talk about moment of inertia, it totally depends on how mass is distributed, right? So if mass is distributed to a longer distance, right? Obviously, moment of inertia would be more. Okay. Now, 13th, angular momentum is again easy formula. 14th, the spherical ball rolls on a table without slipping, then the fraction of its total energy associated with rotation is easy. See, angular momentum is what? R cross P. R cross P. Okay. Right. So obviously R cross P is axial now along the axis. Yes or no? Got it, Harsha? R, just think about it, na, R cross P. Okay. You can get the answer. Yeah, along W, right? Now, 14th one, what is the answer? 14th one, easy. 14th one, what's the answer? Same. We discussed it, right? Almost same. Yes or no? Yes. Okay. 14th one, sorry, 15th one. The thin uniform ring is rolling down an inclined plane with inclination 30 degrees without slipping. Its linear acceleration along the inclination plane will be, tell me. Fifteenth one, everyone, 15th one. right? So we have a uniform circular ring, okay, which is rolling down the inclined plane, 30 degree. So I can say when you talk about this, okay, so in this direction it will be mg, in this direction it will be mg sine theta. Yes or no? Tell me, g sine theta. Agree? Of the center, I'm talking about the center. So we will use the same concept that we have used, right? Okay, so what is the acceleration of center? If it is not slipping, the acceleration of center is equal to what? Right? Yes, it is in science axis of rotation. Tell me. So how come you got G by 3, Harsha? Because sine theta is already G by 2, right? This is G sine theta is G by 2, na? G sine theta is only G by 2. G sine theta is only G by 2. Think about it. Okay. So obviously G sine theta थोड़ी ना होगा. Because rolling के कारण भी तो एक acceleration होना चाहिए ना? Yes or no? Right? Because of rolling also there will be acceleration. Tell me, what would be that? Two racing cars of mass m and 4m are moving in circles of radii r and 2r. Okay, this is also easy, right? 17th is also easy, right? You can solve it now. These are formula putting getting questions, right? 18th one. ABC is a triangular plate of uniform thickness, okay? The side are in the ratio, okay? The sides are in the ratio given, okay? 3, 3, 5. It should be 3, 4, 5 now. Yeah, it should be 3, 4, 5, okay? Which of the following relation is correct? Tell me. Means kiss axis ke long I सबसे ज़्यादा होगा. Tell me what is the answer? 18th one. AB. Because when you talk about I, it is right half mr squared, or sorry, some value of k with mr square, right? So the distance from the center of mass matters. So when you talk about centroid, think about centroid. Right? Which side would be farthest from, which side would be farthest? Because obviously I'm taking either this as an axis, this as an axis, this as an axis, right? So when you talk about R will be the center of mass. How far center of mass is from the axis? Okay? Yes or no? That's what we do, right? Harsha, Manoj, Vishnu? Okay? So what's the answer? What's the answer? सॉल्व मनोज, फोटो देख के नहीं होगा ना, मेरा डायग्राम गलत है इसलिए तुमको शायद दिख रहा है. सॉल्व करो ना एक बार कि सेंटर ऑफ मास सबसे ज्यादा कहाँ होगा. यस हेमिस्ट्री करेक्ट. द आंसर इज बी ओनली. यू हैव टू फाइंड द सेंटर ऑफ मास, राइट? है ना? सेंटर ऑफ मास निकालो, देखो किस एक्सिस सबसे दूर है. एज सिंपल एज दैट. ओके? हर्षा बी करेक्ट, हेमिस्ट्री बी करेक्ट. गॉट इट? टेल मी, गॉट इट? हाँ Harsha, you can do that also. You can do that also, right? You can do that also. ठीक है. सो उसके हिसाब से भी तो उसके हिसाब से तो BC हो गया ना, उसके हिसाब से तो BC, उसके हिसाब से तो B ही हो गया ना, बिकॉज H क्या है, हाइट है ना. ये 3 है, ये 4 है शायद. मैंने बोला ना ये 3 है, ये 4 है ना, तब भी तो BC हुआ. AB कहाँ 4 है? BC is longer than AB ना, right? Got it. Even if you use the formula, right? Still BC, the perpendicular distance, the height of BC is 4. Yes, right? और इसके लिए और कम हो जाएगा, इसके लिए और कम हो जाएगा. Okay. Next. 19th. 19th is easy. Formula putting getting. 20th also easy. Right? 20 is also easy. Yes or no? Tell me yes or no. 20 पता है ना? क्या होगा? A. Very good. 21 easy. 22 easy. Now. 23. Again, 23 is also easy. 24. 24 guys, try solving 24. 24. It is also easy, but basic principle of conservation momentum, right? It is basic principle of conservation momentum, as simple as that, right? Okay, yes. Himashri, Gauri, Varsha, Shreya, Radhika, 24. Try question 24. See, why I'm saying 24, let's see what happens, right? Okay, so thin circular ring of mass m and radius r is rotating around its axis, right? ऐसे rotate कर रहा है. Now, two masses, right? Two masses, two objects each of mass m are attached gently to the opposite end of the diameter like this. Now, think about it. Because of these two masses, is there any external torque? Tell me. Is there any external torque because of these two masses? Think about it. Think like this. No, right? There's no external torque because of these two masses. So what will change? Tell me, what will change? I will change, na? I will change, right? Yes. Yes, angular momentum is conserved. So initially angular momentum was, we know that for ring it is mr square. So initially is capital M r square. Final will be, now since it is at diametrically opposite points, right? We can write it as m plus 2m. Okay, because it is mr square, it is also mr square. So it is 2mr square, right? Okay, into, sorry. Omega I left it, mr square omega mr square, right? And this is r square omega dash. So you have to find omega dash, easy. Very good. The answer is B. Very good. Very good, Shreya. B. Now 25. 25. 25 is easy. 25 is easy. 25 you can solve, right? Okay. Net torque should be 0. 25 you can solve. Try solving 26, everyone. We have solved 26. If you remember, we have solved 26 in classroom. Okay. But 26 is a good problem. So try solving it. I hope all of you remember this concept, right? Okay. That we will have a talk. Okay, we will have a talk on this point and this point. Yes or no? Right? है ना? Got it? So we just have to balance the torque. This clear? Tell me clear? Yes, the correct answer is D. हम लोगों ने solve किया था. ठीक है, just balance the torque, right? Okay. Yes, Manoj, D. Very good. The answer is D. Now, if you see this, okay, so this and this is normal, right? This is normal, this is normal. So हम लोगों ने किया था ना, ये N1 मान लो, ये N2 मानो, ये weight mg है, और ये friction force है, right? Got it? Tell me, got it? Okay. Yes. What is the meaning of LB? LB का मतलब क्या होता है? The answer is in pounds. Okay, you don't have to do anything. Okay, got it? So just balance the torque. Okay, balance the torque because of friction and this, है ना? Clear है? W और scan balance कर देना है. Clear? Everyone clear? Right? Yes. Okay. Now 27 everyone. 27 is easy. 27 you can do. Okay, 27 is easy. 28. Tell me, 28 is the example of parallel axis theorem. We have solved it, right? 28. Okay. So tell me what's the answer of 28? It is based on parallel axis theorem. Yes, very good, right? Because when you talk about across the diameter, it is mr square by 4 and it is shifted by r distance. So plus mr square. C, very good. Okay, very good. Now 29 we just discussed. 29 is repeated question. I hope all of you remember this. 29 is repeated one. Yes or no? 29 is repeated one. Exactly repeated one. Okay. 30, right? Also repeated one. Yes, 30 is also repeated one. Okay. Now 40, sorry, 30, 31 easy, 31 easy. 32, okay, 30 we have solved. Now 30 we know, right? 30 all of you can solve, right? Guys, 30 can solve now. Yes or no? Right? We discussed it now. Okay. 31 easy. 32. Try solving 32, everyone. 32. Try solving 32. Guys, 32. Try it. A wheel of radius r, sorry, 1 meter, rolls forward half revolution or horizontal ground. The magnitude of displacement of the point of wheel initially in contact with the ground is, it is very easy problem. Okay. But students make mistake. That's what I'm saying. No Manoj, no Vishnu. You guys are wrong. See, that's the thing, right? It is the hypotenuse, right? Think about it. When it is rolling, okay, think about it. Think about it, guys. When it is rolling, suppose this point, right? This point, after rolling, this point will come over here. Yes or no? And it will cover this distance. Got it? So this distance is pi r, and this point will be here, which is, tell me, diametrically opposite, diametrically opposite, which is 2 meter, right? So this is a displacement now, right? Yes or no? Tell me, yes or no? This is a mistake that all of you did, right? Got it? Tell me, got it? Yes, Himashri, correct. Answer is D. Answer is D. Okay, got it? Because generally you won't, yeah, in exam also you won't think, you will say, okay, it will be pi, half will be pi, but it won't be, right? The points that you are taking are different. Okay, now 33, solve 33. Guys, 33 is a very basic problems of moment of inertia for continuous mass. 33 is a very basic example of moment of inertia of continuous mass. Tell me. Think about it. Thirty-three. Okay, right? RCM is equal to integration of dm. Tell me, into R by integration of dm. Yes or no? How many of you remember this? Right? Yes, Harsha. Answer is D. Right? Answer is D. Now, here the linear mass density, right, of length 3m is proportional to x. Means lambda is directly proportional to x. Okay, right? Got it. Lambda is directly proportional to x. Okay, so I can say, okay, lambda is equal to kx. Easy, right? So what is dm? dm is equal to lambda dx, right? Which is lambda, sorry, kx dx, and here we also had x, sorry, this is also x. So it is kx square dx. Anyone have any issue in this? Tell me, anyone have any issue in this? Divided by kx dx, integration of. Okay, now you just have to put and get, simple, as simple as that, right? So, okay, if you put and get your answer, 3 will be cancelled because length is given as 3. Okay, because here one additional 3 will come now. The answer is 2. Okay, yes. Center of gravity, etc. of mass usually they are the terms which is used But okay, everyone, my voice is audible. Voice is audible, yes or no? Hello, mic check, mic check. Audible, right? Okay, it's audible now. Okay, yeah. So this is the basic definition, basic formula for continuous mass distribution. Yes or no? Now we know that. Okay, we know that lambda is given by kx because it is directly proportional to x. So dm is equal to lambda into dx, which is kx into dx, right? Okay, so here we will say RCM, right, is equal to integration of kx. Now this is also one x, so x square dx, integration of kx dx, right? Now it is 0 to 3, 0 to 3. So it will be what? Integration would be kk will be cancelled. It will be x cubed by 3 divided by x square by 2. Now here 3 cubed by 3 will become 3 square, 3 square, cancel, 2 will go upside, we'll get 2m. Got it? Tell me, got it? Yes? Clear? Chemistry, clear? Okay, next. 34 easy, you can do 34, right? 34 you can do. 35, again 35 is a theory. Let's see 35, please solve question 35. It is a concept. Okay, it is based on concept. Tell me 35. I guess today we'll be just able to complete, even not complete this, right? So I guess today we will be solving 2 days. It will require just for NEET previous year. If you won't solve, if I go through all the problems, right, it will require 2 days for NEET previous year only. Okay, Mashri? Okay, Manoj? Yes, Shreya, very good. The answer is B. Okay, the answer is B. Let's see why. A composite disc is made up of two equal masses of aluminum and iron so that it has high a moment of inertia as possible, high as possible. Okay, right? This is possible when the surfaces of disc are made up of iron with aluminum inside. Now think about it. Think about it. What's the formula for moment of inertia? Tell me. Tell me. Integration of r square into dm now, right? For continuous matter is in integration of r square dm, moment of inertia formula, right? So obviously, when you talk about mass, totally depends on density, right? Yes or no? So जितना heavier mass ज़्यादा होगा तो moment of inertia ज़्यादा होगा. That's what the basic meaning of moment of inertia, right? Distribution of masses. Okay. So mass of iron is greater. Yes or no? Right? So obviously iron mass should be, yes, outer rim, right? Should be inside. Okay. Got it? Harsha, got it? Next. Okay. Okay. Now 36 easy, 36 हो जाएगा, 37 हो जाएगा, 38 almost repeat question. 38 भी हो जाएगा, ठीक है, 38 भी हो जाएगा, रिपीटेड क्वेश्चन। बस यहाँ पे वैल्यू की जगह के दिया हुआ है, हम लोगों ने सॉल्व किया हुआ है वैल्यू लेकर, है ना। 39 अगेन हम लोगों ने किया है, राइट, mgs इज इक्वल टू दिस 40 किया हुआ है हम लोगों ने, 40 कंजर्वेशन मोमेंटम टाइप सेम। ओके, रिपीटेड क्वेश्चन जो है, रिपीटेड कॉन्सेप्ट वाले हैं, वो मैं स्किप कर रहा हूँ, ठीक है, तुम लोग आराम से कर सकते हो। 70 प्लस है हर्षा। विष्णु देखो, मास, हेवियर मास डिस्ट्रीब्यूट बाहर की तरफ ज्यादा होगा ना, जस्ट इमेजिन, टोटल मास तो सेम ही है ना विष्णु, टोटल मास कहाँ कम हो रहा है? It is the distribution, moment of inertia depends on distribution, right? Mass would be same only, na? If heavier matter is outside, right? अरे मास इज सेम, इट्स नॉट कि तुम अंदर कर रहे हो तो आयरन ज्यादा हो जाएगा और एल्यूमिनियम कम होगा, ऐसा कुछ नहीं है। यू आर थिंकिंग लाइक दिस कि यहाँ पे पूरा आयरन है फिर थोड़ा सा एल्यूमिनियम है, ऐसा नहीं है। दे आर हैविंग सेम मासेस, राइट। जो तुम डिस्ट्रीब्यूशन ले रहे हो उसमें मास तो कांस्टेंट रहेगा ना, आयरन एल्यूमिनियम को दोनों का, कोई ना एक केस में तो मास ही चेंज कर दोगे। Again, whenever we do that, whenever we compare, we keep something constant, na, right? So it is understood कि मास चेंज नहीं हो रहा दो केसेस में, राइट, सेम मास को हम अंदर और बाहर कर रहे हैं। ओके, 40 अगेन एंगुलर कंजर्वेशन, सो 40 इजी है, मैं वही क्वेश्चन कर रहा हूँ जो थोड़ा सा भी कॉन्सेप्चुअल रहेगा, ठीक है। 41 इजी है, टॉक बेस्ड। ओके, 42 इजी है, 43 again parallel axis theorem, 43 parallel axis theorem, right, parallel perpendicular axis theorem। 44 again angular momentum conservation। 45 सेम इन मोमेंट ऑफ इनर्शिया फाइंड करना है। 46 पैरेलल एक्सिस थ्योरम, बिकॉज 70 प्लस क्वेश्चंस हैं, ठीक है, तो नहीं हो पाएगा। जो सेम क्वेश्चन है ना, मैं उसको भी नहीं डिस्कस कर रहा क्योंकि तुम लोग कर सकते हो, ठीक है, जो ऑलरेडी सेम कॉन्सेप्ट क्वेश्चंस हैं। नहीं हो तो नेक्स्ट क्लास में डिस्कस कर लेंगे, डोंट वरी। 48 theory, okay, 48 you can solve now. 48, think about it, what's the answer? 48, it is theory, it is basic concept, right? 48 बताओ, 48 48 everyone, 48 is just a concept, tell me। 48 मनोज गलत है, विष्णु करेक्ट, हर्षा करेक्ट। 48 कॉन्सेप्ट एक बार देख लो। बेसिक डेफिनेशन है, बेसिक डेफिनेशन वर्क एनर्जी थ्योरम। क्या होता है बेसिक डेफिनेशन? टेल मी। वर्क डन प्लस हीट, everything is equal to change in kinetic energy, right, which is all kinetic energy, okay। Right, so answer is D, Manoj, answer is D। Okay, 48 answer is D, everyone, 48 answer is D, okay, got it। Okay, now 49 same parallel perpendicular axis theorem, you can solve 50। Now 50, if you think about 50, right, 50 you can solve, but we have solved 50, if you remember, right, if you remember, we have solved exactly this question in fluids, yes or no। टेंशन निकालने के लिए याद है किसी को? How many of you remember? Tell me, how many of you remember? Tension निकालने के लिए, right? If you remember, you can just tell me the answer. Tell me, what's the answer? Tell me, what is the answer? Because when you talk about force exerted, it is basically tension, na, right? So what was the answer? Without even solving, without solving. See, you can eliminate two options. You can eliminate actually two options by dimensional analysis. Yes or no? Two options will be eliminated by dimensional analysis. Okay, right? Because obviously force का dimension ही नहीं है ना? Clear है? So बचा दो option, right? Either B or D. नहीं ना, A और C wrong है ना? A और C wrong है ना? Right? So B or D, and we know that when you talk about length having mass, half, right? Half हो जाता है, yes or no? इंटीग्रेशन में क्या होता है? X का इंटीग्रेशन होता है तो x square by 2 आता है. So the answer would be D. Got it? Right? हम लोगों ने already fluids में निकाल रखा था tension. Now, 51 is basic, 51 is easy. '52, tell me, 52. 52. 52 is very basic question, right? Very basic question, but I want you to solve it. We have done this problem. I hope all of you remember, we have done this problem in class. Everyone, tell me. How many of you remember? We have done a similar problem like this. याद है? विष्णु गलत कर दिया ना तुम? I told you, right? Center of mass यहाँ होगा, right? इसके कारण torque लगेगा, right? तो उसके कारण alpha create होगा. Yes or no? So torque is equal to I alpha. Just have to do that, right? And यहाँ पे तो I given है. I is given. Yes, Manoj, correct. The answer is C ना, because यहाँ पे ये कितना है? What is this distance? L by 2, right? Got it. So torque will be what? Mg into L by 2 is equal to I alpha. That's it. That's what you have to do. Okay, so the answer is C. Yes, answer is C. Class में किया हुआ है हमारा ऐसा problem. Okay. Now 53 याद है? 53 याद है कि नहीं? हम लोगों ने अभी किया ना 53. हम लोगों ने न्यूमेरिकल सॉल्व किया था, याद है कि नहीं? स्टार्टिंग वाला, राइट? सेम था ऐसा. परपेंडिकुलर डिस्टेंस बस निकालना है, राइट? सो टेल मी 53 का आंसर बता दो. सॉल्व नहीं करना है, बता आंसर क्या होगा 53 में? यस, y इज इक्वल टू x प्लस 4 वाला. सेम टाइप है ना, सेम टाइप है. टेल मी परपेंडिकुलर डिस्टेंस क्या होगा? नहीं ना हर्षा, नहीं ना, बिकॉज अगेन डायरेक्शन की बात हो रही है. इट इज जस्ट डायरेक्शन. तो ये यहाँ रहे, यहाँ रहे, यहाँ रहे, यहाँ रहे, क्या फर्क पड़ता है, राइट? इट इज अ वेक्टर ना, राइट हर्षा? राइट? थिंक अबाउट इट. It would be same ना, it would be same, right? But it's a vector. R vector है वो, जिसका डायरेक्शन वो है. तो A पे रहे, B पे रहे, डायरेक्शन तो वही है ना. परपेंडिकुलर डिस्टेंस तो सेम ही होगा ना. Yes or no? Tell me, right? So perpendicular distance is same, right? Okay, and it is said that mass is same. Okay, velocity is also same. Got it? Right? So obviously it will be equal. Got it? Tell me, got it? Yes or no? Everyone got this? Okay, very good. Now 54 easy, right? Radius to gyration का ratio निकालना है. Okay, 55. 55 हम लोगों ने किया है, एल शेप वाला, याद है कि नहीं? एल शेप वाला, आई होप ऑल ऑफ यू रिमेंबर वी हैव डन दिस 55 एल शेप वाला, राइट? So I hope you can solve it. 56 repeated question. 56 exactly repeated question. 57. 57 is conceptual theory. 57 conceptual theory. You can solve f or t के बीच में distance and sorry angle and all those things, right? 57 you can solve. 58 yes you can solve. 9 formula putting getting. 9 formula putting getting, right? Okay. 60 seems good question. Circular part, 60 is good question. Try solving 60. 60 is good question, everyone. 60. Try solving question 60. We will complete the NEET one. Okay, we will complete the NEET one. It will take till 1:30. Okay, most probably 1:15, 1:30. Okay, we'll try to complete the NEET one. Okay. Try solving question 60. Everyone. So the answer is D. The answer is D. Now think about it. A circular disk of moment of inertia it is rotating in a horizontal plane, right? It's symmetry axis with an angular constant speed omega I. Another disk of moment of inertia ib is dropped coaxially onto the rotating disk. Okay. Initially, the second disk has zero angular speed. Now think about it. Now it is rotating like this, right? ऊपर एक और गिरा दिया गया, right? So obviously, क्या होगा बताओ? Angular momentum conserved रहेगा. As simple as that. Yes or no? Right? Yes or no? But kinetic energy change होगा. Now when you talk about angular momentum conserve होगा, initially wi दिया हुआ है और इसका it दिया हुआ है. So initial angular momentum कितना होगा? it into omega I. Now finally क्या हो गया? ib drop कर दिया गया. So it will be ib plus it into omega final suppose. Right? So omega final निकल जाएगा. Omega final निकलेगा. Yes or no? Tell me yes or no? Right? Okay. Now we know that when we talk about, yeah. So what you have to find, both the disks are rotating with constant speed omega f. Okay. Right? The energy lost by the initial. So energy lost कितना होगा? Final minus initial. Yes or no? So initial minus final. Initial minus final. Right? That's the loss of energy. Initial क्या होगा? Half I omega I square minus final क्या होगा? Half I total into omega f square. As simple as that. That's it. What you have to do. Got it? This is what you have to do. Yes or no? Tell me. Yes or no? Right? So you will get D as an answer. As simple as that. Okay. Right? Got it? Okay. So 60 was a good question. After 60, 61. No, 61 is easy. 62. 62 is theory. I hope all of you already remember, right? mr square is less than mu mg. Yes or no? Right? 63, no. 64, theory, parallel axis theorem. 65. Okay, guys, try solving 65. 65. Everyone try 65. Try 65. Think about it. 65. Everyone. Guys, try solving 69. Everyone. See or not? So what is given? A circular platform is mounted on a frictionless vertical axle. Okay. The radius r is equal to 2 meter and moment of inertia of the axle is this. It is initially at rest. Okay. 50 kg man stands on the edge of the platform and begin to walk around the edge. So I hope all of you have seen this kind of problems. Na? यहाँ पे right? ये अगर चलने लगेगा इधर, okay, चलने लगेगा तो क्या होगा बताओ? Think about it. Tell me. There is no external force now when you talk about, right? When you talk about the axle, the platform, and the man as one system, there is no external force. So momentum to conserve rahega. Yes or no? Right? Yes or no? Yes. So because he will walk, there will be momentum. So I can say initially when it is not walking, initial momentum kitna hai? Zero, right? Initial angular momentum zero hai. Now, when it start walking with speed v, right? So I can say अगर ये v से move करेगा तो ये इधर I omega से rotate करेगा. So I can say final momentum, right? L2 is what? Tell me, mvr minus I omega. Yes or no? Tell me, yes or no? Right? और ये क्या है? ये platform है, circular platform है. So I can say here omega is equal to, right? After solving, omega is equal to what? I is given, m is given, right? V is given, everything is given, right? So omega is equal to half. है ना? सब कुछ दिया हुआ है, omega half निकल गया. क्लियर ये चीज? यहाँ पे दिक्कत किसी को नहीं? Okay, now next question is time taken by the man to complete the one revolution. Now think about it. Now man is also moving and this is also rotating. Yes or no? So here we will use the concept of, right? Here we will, yes, V is with respect to round. Okay. So here we will use the concept of relative. Tell me. Yes, relative velocity. So ये इधर मूव कर रहा है v velocity से और ये इधर मूव कर रहा है ओमेगा r velocity से. तो relative velocity क्या होगा? v plus omega r. Right? This is relative velocity. Yes or no? Into time is equal to what? अगर अपने same position पहुंचेगा, so distance should be 2 pi r. Got it? Tell me, got it? Right? So you can get time, है ना? You can get time. Clear? Right? Clear? Yes? Okay? Very good. Very good, everyone. So next is 70. Now there was 72. 72. Right? 72. How many of you remember? Tell me. Tell me. Anyone remember this? स्टार्टिंग में क्वेश्चन आया था ना? स्टार्टिंग में क्वेश्चन आया था कि नहीं? राइट? स्टार्टिंग में जो क्वेश्चन था वी निकालने वाला, सेम क्वेश्चन है, उल्टा पूछा गया है. राइट? उस केस में हाइट दिया हुआ था, राइट? और वेलोसिटी पूछा था, है ना? Yes, very good. So the answer is C, disk. The answer is C, disk. Okay, same thing you have to do, right? Now 70, yes, 73. I hope all of you can 73. 73 हो जाएगा. हम लोगों ने अभी किया है सेम क्वेश्चन. 73 सेम वन. L/2 यहाँ पे लग रहा है, सॉरी mg/2 यहाँ लग रहा है, right? That should be equal to I alpha. Same, exactly same question. And 74, 75 is, tell me, 74, 75 is also same angular momentum conservation. Okay, in 74, right? Go through question number 74. Everyone go through question number 74. 75 is easy. 75 is easy. Actually, 75 is very easy. 74, just go through question number 74. It is the last problem of previous year. Go question number 74. Yes, yes, conservation momentum. Yes, very good, Harsha. The answer is C. Yes, the answer is C. कर्नाटका होगा. नीट कर्नाटका. I don't know what is नीट कर. पता नहीं हर्षा. Like शायद उस वक्त होता होगा. ठीक है. The CET Karnataka has a highest number of seats in NEET, like per state, I guess. So Karnataka is having 8,500 seats.